Hi guys, today we'll understand difference between IPS and IDS. These are the two topics for today's class. See, IPS or IDS are not the two different devices. These are same device, right? Only the deployments of a sensor decides whether it's an IPS or it's a IDS. If you remember in yesterday's class, I had shown you the interfaces, right? That was the sensing interfaces. So if you basically combine two interfaces together, that becomes IPS. So traffic will pass through one interface, exit through other interface. This becomes IPS. Whereas if I have a single interface and this single interface is used only for receiving RX, right? This is called IDS, used for detection system. So how does it work? Where do we deploy? Let's see all this stuff. See, intrusion prevention, when I talk about, it is used for preventing your real network, your real packet, your real data. When I say IDS, IDS is used for detection. It works with copy of packets, does not block or does not prevent you from the real attacks. It basically analyzes the copy of packets, not the real packet. So how is it deployed? Let me show you in the next slide. Okay. Now here if you see, in this slide, we have sensor deployment modes. You can see here, sensor deployment modes, right? Sensor deployment modes. Inline modes or IPS, both are same. Inline, IPS, these are same terms. Sensor is in a data path. Sensor is in a data path in the sensor. You can see here, I have ASA, I have IPS, and this is my internal network. Here I have IPS deployed after the firewall, right? And this IPS has two interfaces. Let's say this is G0 by 0 and this is G0 by 1 interface. Two interfaces we have. If we combine these two interfaces and if packet passes through one interface and exit through the other interface, this type of deployment is called IPS deployment. So your packet has to enter through one interface and exit through the other interface. This type of packet passing through a device is called IPS deployment, not a IDS. That's why we say sensor is in a data path. It means sensor is deployed in a such a way your data has to pass through the interface of your device. That's why we call it as a IPS device. Now, sensor analyzes actual network traffic. Now, listen here carefully. Is there any other way that data can reach to your corporate network? Is there any other way? No, we don't have any other way. There is only one way that your data can pass, and that is through IPS. That's how your network is designed. That's why we say IPS is deployed at data path, right? Actual traffic is being analyzed. There is no copy of packets. It's an actual traffic. Now, sensor can drop malicious packets before it reaches to intended target. What does it mean? Let me tell you. For example, if any attacker are there, if let's say I have attacker over here, right? So this guy, if he tries to perform an attack, right, to a target, can he directly reach? No. First, it has to decide with firewall. Firewall will decide whether this guy can enter the network or not. That's a first barrier. Second is your IPS. Your IPS decides or it looks into what is inside a packet. Now, this is what you have to understand. Firewall can see whether this guy can be allowed or not. But firewall can't decide what is inside a packet. Like, is it malicious? Is it carrying any, virus or anything? So it basically looks into what is inside a packet. This is the task of your IPS. So if user is carrying any malicious data, knowingly or unknowingly, in any way, this is the place where it gets filtered. IPS is strongly standing between your external and the internal network, where it filters all the type of attacks. This is called basically IPS. Okay. Now, considered as an IPS deployment, not an IDS deployment. And one thing I'll tell you, disadvantage of this deployment. See, if every packet has to get passed through the IPS, if everything has to get checked, definitely high bandwidth requirement will be there. Just imagine on a road, if there is a traffic police checking each and every vehicle, definitely there will be a traffic jam, right? Same thing here, it happens. So if you have to check all the packets, then definitely high bandwidth will be required. In such cases, we need to increase our bandwidth of a network. Now let me show you IDS. So in the next slide, we have IDS here. IDS, we also call it as a promiscuous mode, right? This is also called as a promiscuous mode, right? Okay, we also call it as a promiscuous mode, IDS mode, passive mode, tap mode. Everything has the same intention. Different terms are used, but the task is same. Now what happens here? Listen carefully. Sensor is not in a data path. How? Let me make you understand. Let's say this is a topology. This is outside interface, inside interface. At outside VLAN, I have connected one IPS sensing interface, only one sensing interface, not two, right? And this sensing interface is configured in such a way so that it can capture a packet. See, your real data will go like this, and copy of packet, your copy of packet, at the same time copy of packet will come to sensing interface. Understood? So first thing, sensor is not in a data path. I believe this is clear here. Second, sensor analyzes copy of a network traffic, not an original packet. Copy of a network traffic. Do you understand? Copy of a network traffic means, as I told you, your real data is passing this way. At the same time, on a switch, we configure copy of packets, right? And the copy of packet will come like this to your sensing interface. We have only one sensing interface connected here. This is management interface, right? Through which we control IPS device, right? So it's very clear. Sensor analyzes copy of network traffic. Sensor has limited prevention capability. Actually, it has only analyzing capability, not a prevention capability. Okay, there are prevention capabilities. Later it gets triggered, then it will take an action by the time your attacks will happen. Okay, so this is not the mode which is deployed for prevention. This is used only for detection, considered as an IDS deployment, not an IPS. So as we don't have to check each and every packets, so the advantage of promiscuous is it does not affect a bandwidth of a company. Definitely no system check, no packet filtering, so bandwidth will be definitely okay, right? Disadvantage is it can't stop a malicious packet, right? As you know, it is deployed only for detection, not for a prevention, right? Okay, now let's see the next slide. Here we see how actually copy of packet happens. Now let's say here I have attacker, or let's say here this is a guy who is actually generating a traffic. Let's understand that this is our employee, right? This is our employee and this is IDS, where I need a copy of packet, and it is connected with single switch, right? If it is connected with single switch, in that case there is a technology called as a span. We call it as a span technology. Remember, in a single switch from one interface to other interface, if I have to copy a packet, then we use a technology called as an span technology. Okay, if you guys are not aware of what is a span, you should learn. Span is one of the technology that can be used within a switch to capture a packet, where I can make one interface as a source, another as a destination, or I can make this source, another as a VLAN. Okay, I can make, there are multiple ways. When you know the technology, you will come to know. So you can make this interface as a source, and destination you guys can make any VLANs, or you can make any interface directly. In a case of a span, within a switch, if I have to capture a packet, we use span technology. So you can understand this is kind of IDS, sensing interface connected, where copy of packets will keep coming. Okay, this is called IDS deployment. I mean, in an IDS deployment, this is the way we capture the packet to our interface. Let's say if I have multiple switches, then in the next slide we can see, if I have a multiple interfaces, then how it works. See, in that case, we'll use RSpan technology. RSpan is nothing but it's a switch port analyzer, right? A remote switch port analyzer. Okay. So let's say if I want to send packet from here, okay. So here I'll make it as a source, and destination I'll make it as a VLAN. Okay. I'll make destination as a VLAN. Okay, so this interface will become source, and I'll make RSpan VLAN, RSpan VLAN. Let's say I'll make 555 as a RSpan VLAN. So if this is server and these are clients, so this RSpan will be propagated here, here, everywhere, right? So from here packet will get generated, it will reach to RSpan VLAN, and RSpan VLAN from here on this particular switch, I'll say my source is VLAN 555, right, and destination is my interface FA by 01 interface. So guys, this is how in a case of RSpan, we copy a packet from different switches. Your traffic passes through a different switches, and packet is being captured at the interface. Instead of Y-shark logo, you can understand there can be a sensor of IDS, right, which can be used to capture the packet. So guys, I believe I'm clear to you. You understood in today's class that IPS and IDS are two different deployments. These are not two different devices. So it all depends on your sensor, how you deploy. Two sensors together becomes IPS, single interface becomes IDS. It's all about deployment of your sensing interface. Thank you. See you in the next session.